There we go. Let's get some action. Get our stir bar going here. We can do some experiments. Oh, let's see. There we go. Nice little spin rate. Pop in some water. Okay. Got a nice little vortex going there. All right, I'm going to add some universal indicator here. See what happens. Hi, Asfara. How are you? Hey, Matt. A little live chemistry. I am going to be doing some chemistry experiments. So right now I'm going to add some universal indicator to this flask that's stirring on a magnetic stir plate. And you can see from the color of the universal indicator that the fluid, hello, Ewan, it's like litmus. Yeah, it's a little bit like litmus, except this displays a lot more colors than litmus. So these are the colors that the universal indicator will display at different pH values. You can see we're at a green pH, and that tells us, hi, Datan. This tells us that the water is neutral, pH 7. So check out what happens here when I add a little bit of acid to the flask. A couple drops up here at the top, 2 drops. The acid I'm adding is hydrochloric acid, same acid that's in your stomach. And we see a lot of different colors, don't we? Notice that in the middle of the vortex, it remains kind of red. And that tells me that the acid is pretty much staying concentrated in the center. Yep, hydrochloric acid. It's staying concentrated in the center. And over time, it slowly gets pushed out to the sides. Yeah, Matt, the universal indicator is going to be a mixture of thymol blue, phenolphthalein, and bromothymol blue. There's a variety of different mixtures that they use for universal indicator, so I'm not 100% certain that what I'm telling you is true, but I am pretty sure that at least thymol blue and phenolphthalein are in the universal indicator. Let's add a few more drops of acid here in the center. And yeah, you can see the red color tells me the center of the vortex is like a low pH, and then on the outside it's like pH 6. And then as the material gets pushed down the vortex, it hits the stir plate, and then it gets pushed out along the sides, and then the whole mixture homogenizes. It looks like we're about a pH of 3 now. The stirrer I'm using is from Intel Lab. I bought it online for about 30 bucks. Tollens reagent, if I remember correctly, that's going to be a mixture of silver ions and some other, and that's a test for reducing sugars, yeah? Yes, indeed. All right, so now we got a nice red color. Let's add some sodium hydroxide base. I'll add 2 drops here to the center, and the chemical reaction that'll be going on will be sodium hydroxide reacting with the hydrochloric acid, and those will get neutralized, right, to water and salt. Unless I got, excess of base. So let's see, I'm going to add 1, 2, 3 drops. As you can see the whole rainbow. Isn't that beautiful? Very beautiful. Yeah, I use red cabbage a lot too. Although I was able to buy some universal indicator online for, about a half liter for 10 bucks. Isn't that beautiful that you see all the different colors of the rainbow? What happens to the effect of freezing point on increase in pressure? Well, that's going to depend on the phase diagram, right? With water, which is an odd material, water, increase in pressure causes that's going to be what? That's going to change from a solid to a liquid, so that's going to lower the freezing point. But with most other stuff, it's the opposite. Crystal art. Yeah, I am a professor at a university. So here we go. A few more drops of the sodium hydroxide. We got a few drops of base. Okay, yeah. What I'm adding now? I'm going to be either adding sodium hydroxide, 20% solution, or I'll be adding hydrochloric acid to acidify the mixture. So right now we're at a very high pH. So here are the different colors you're going to see at the different pH values. Right now we're like somewhere around 9 or 10 with the aqua blue color. Excuse me, the violet blue color. And as I start to add acid to this, the pH should drop. If we get to neutral, it'll be green, and if it gets more acidic, we'll get, the yellows, orange, and red color. So here we go. I'm on a couple drops of acid here. Here we go. 1, 2, 3 drops. Let's see what happens. You can see that red color in the middle. That's like a pH of 3 or lower. And then as that material hits the stir bar, yep, adding acid or base, Asfara. You can see as that hits the stir bar, it gets pushed out along the side, and it looks like our pH has dropped right now to about a pH of 8. Now it's about 7. I think that's where we're going to stop. Maybe it's going to go a little further. Let's help it out. We'll add a few more drops of acid here. 1, 2, 3. Let's see what happens. Very beautiful. Sometimes it's fun enough for me to slow the stir rate down just a bit. Oh, I slowed it down too much. Knocked my stir bar out of orbit. Let's try getting it back going here. There we go. There we go. All right. A few more drops of acid will get us down here to pH of 3, I'm hoping. And then we'll send it back in the other direction. Interesting. Very interesting. Looks like, man, I didn't get it. We got to keep going here. I'm only like a pH of 4 or 5. There's 3 more drops. That'll get us to a lower pH. There we go. Nice low pH. All right, let's add some base, head it back in the other direction. Here we go. 1, 2, 3, 4, 5. Let's see if we get that rainbow effect going on. There it is. For organic. I don't teach much organic, so I use Morrison and Boyd back in the day. I don't even know if they still have a volume out. Unique time. I also used one by Seon E.G. I'm not sure how to say her last name. Both of those were perfectly fine for me. Last time I had a class in organic chemistry, I think it was around the year 2000. It's been a while for me. Been a while. Oh, I think I got a little bit of base on my hands. Excuse me, I'm going to have to wash this off. Oh, and the stir bar gets knocked out of orbit. I can tell there's a little something going on my fingers, so I better rinse this off. Yep. My fingers are feeling a little bit slippery. I'm going to put a glove on. All right, I got that rinsed off. Let me get my glove. It's still a little bit soapy. Let me just, there we go. Get that rinsed. All right. Here's my glove. Look at that. It's a nice little green going on there. All right. Yeah, I mainly do, well, man, I've done inorganic, I've done general chemistry, I've done physical chemistry, and I have done analytical chemistry. Finals of the World Cup, huh? That's cool. There we go, adding a little acid. A little more acid. Matt, well, how about you? What branch of chemistry are you studying? Scott, is it possible to make a perpetual color change with acids, bases, and universal indicators? If you mean by perpetual, like what I'm doing here, by adding, notice I'll add, the different material, and then we'll see the various color changes. Yeah, that's exactly what we see going on here. But if you mean just setting everything up and then having it oscillate, those are a little more difficult to pull off, but those can be done too. There you can see. Adding some acid, and we're sending it back in the other direction. So I've got universal indicator in this flask. And then I'm just adding hydrochloric acid or sodium hydroxide. And these are the different colors that you're going to see at different values of pH. As it gets more basic, it gets more violet in color. As it gets more acidic, it gets more red in color. And if we're neutral, we're going to have a green color, pH neutral. Would this work better if there was a buffer in it? Well, Sly Fox, if there was a buffer in it, it'd be a little tough to see the drastic pH changes that I'm seeing upon addition of the acid. And so you wouldn't get the quick, drastic color changes that I'm observing upon addition of acid or base. Organic or general? Nice. Nice, Matt. So here, check this out. I'll add like 3 drops of base up here at the top. 1, 2, 3. And we may get the whole rainbow. You see that, Sly Fox? So with a buffer, which resists changes in pH, you wouldn't see that, right? Yeah. And the reason why you see that rainbow is because the chemical reaction between the acid and base takes time. And so you'll get different regions of pH set up. You can also tell sort of that the material that I add tends to stay concentrated in the middle of the vortex. And then over time, it either spreads out or it gets it gets pushed off to the sides by the stir bar. It is cool. It's a very beautiful effect. It's a very interesting effect. Thank you, Sly Fox. I appreciate it. 1, 2, 3. Another drop will get us at the high pH value. And then, yep, add some salty water. Well, at this point, it's got a lot of hydroxide, right? We got an excess of hydroxide. Let's make salt water by adding the acid. So when you see the green color, that's when we've got salt water. And of course, in the indicator as well. You can see the red in the middle where the acid is. And then we're going to see what happens here after the reaction stops. If I can ask, how would you make the bottom basic and the top acid? I'll show you how we can do that. So you want the bottom basic. All right, check this out. This is how we do it. We're going to make the whole thing basic to begin with. All right. All right, so that's basic. And now, what I'm going to do, I'm going to rinse my hand off. This bottle's leaking a little bit. I think that one's ready to get thrown out. All right, now that I got the whole thing basic, I'm going to slow the stir rate down. So it's just barely going. Just a bit. Come on, man. There we go. It's getting knocked out of orbit. Just a little twirl. I don't want much. This might do it. Now I'm going to add this acid here. All right, here we go up at the top. I'm going to turn the stir off. And there we have it. You can see now that the top is acidic, right? A pH of like 3 with the red color, and the bottom's basic. Isn't that cool? You know, I live stream usually for an hour. Usually I go on TikTok. I get a lot more views over there on TikTok. Yeah, I usually go for an hour. I probably won't go an hour here, but we'll see. And if I can ask, how much did you pay for the pH indicator? Oh man, $150 for 30 mils. That is, you know, I was able to buy this bottle for $10. 500 mils for $10 online on Amazon. So that is cool, isn't it? You ready to spin it? Y'all let me know if when you're ready for me to spin it up again. Thank you, Idithian. I appreciate it. Adithya. Thanks, Sly Fox. Hello, Rose. Very pretty. My TikTok, it's Tommy Technetium over there, but my handle is Chem Stud. So that's like short for physical chemistry stud. I know it's just a stupid name, but so yeah, I'm Tommy Technetium over there. I'll probably stream on TikTok. Oh, I'm saying sometime this afternoon. So be checking that out. I guess I can. Here, I'm ready to. Wow, that actually is kind of cool. Just watching it slowly do its thing. I see some different colors in there swirling around down near the bottom. How about y'all? It's really kind of pretty. Let's try it the other way. So now this time we're going to try, we'll try acid all the way through, and then I'll add a bunch of base at the top. Because this time, remember, it was base all the way through, and then I added acid at the top. So we're going to reverse that this time. So I'm going to get it spinning, stop the spin, and now I'm going to add a bunch of sodium hydroxide to the top. So here we go. You can see the color change. So now it's reversed. Bunch of base at the top, and we can watch what happens here. I see some green developing. So yeah, the universal indicator, it follows the colors of the rainbow. Well, I don't know, these gloves, they're pretty thick. Yeah, the pH indicator follows the, you know, the order of the rainbow, with red at the low pH and violet at the high pH. Do you do any other experiments? How do you know this glass you're using won't etch from the sodium hydroxide base? Glass, you know, that's a good question. In my experience, glass doesn't etch from sodium hydroxide. In my experience, I'm not saying that sodium hydroxide doesn't etch the glass, but yeah, I use sodium hydroxide a lot with various glass beakers, and I don't have it with any trouble. Hey, thank you, B63. Appreciate that. So maybe, Matt, you can tell me if you've got a different experience using sodium hydroxide with glass. So it might be something I'll look out for. Traditional water, it will not eat it here with him at the same hydroxide. It's my experience here, Sly Fox, as well. All right, I think this is kind of stopped, so I'm going to go ahead and spin this. Get her spinning again. I once melted crayons on a scale, and the scale burnt and fumed of plastic. Oh, man. Crystal art only use it with borosilicate glass. This is not borosilicate glass. But I've been using these flasks for a really long time with these experiments with no issues. So, the hydrofluoric acid, That's a different story with glass, right? That'll etch some glass. That'll get your glass etched. All right. Let's add some acid to this mix and see what happens. I'll add a bunch of acid and then slow down the stir here. Let's see what happens. That's a nice, look at that. We got the rainbow going on a little bit. We got red, a little bit of, just a bit of yellow, green, and blue and violet. How do I get the card? I'm not sure what you mean by the card. Boy, that's really cool. That's a nice effect. That's really beautiful, isn't it? It does look cool as far. I agree. It's really, hey, Caleb, how are you? It's good to see you. How do you like this rainbow effect we got going on? It's pretty. Very pretty. It's nice. It's beautiful. Very beautiful. All right, let's mix her up. Oh, the YouTube card. I just printed these out. Yeah. You can take a screenshot of it if you want, I guess. I'll leave it down there. Very beautiful. Thanks, Caleb. Yeah, this one, as far, I think that's what you're asking for. I just printed them out, so they're just like a, I guess a business card or something that I use for my channel. Let's mix it up, see where we're headed. Looks like it's going to be orange or red. Let's get it all the way to red. Then we'll add a bunch of base at the top. How do you make sure something doesn't precipitate when adding acids and bases over and over? Well, because the salt that's formed, Rose, the salt that is formed when you mix sodium hydroxide and hydrochloric acid, the salts that forms is just regular sodium chloride table salt, and that is very soluble in water. It dissolves in water really well. And because of that, you don't get any precipitation. It just dissolves in the water. Hello, Detonator. I need a bumper sticker, huh? That's funny. Oh, you lost a match. That stinks. How much water is there? I'm going to say about 1.5 liters. Roughly, is my guess. It does look like a nebula a little bit. Like a rainbow nebula. I agree. Give it a quick stir. And turn it off. Watch what happens. It's pretty. Very pretty. Give it another quick stir. Turn it off. Huh. All right, now we're going to add a bunch of acid up at the top. So we're going to have 3 different layers. Let's see what happens here. Thanks, Sly Fox, for looking that up. I don't even need to watch the Mash the Neighbors. That's funny. The neighbor's telling you what the results are. Love it. Stirring it up. Be interesting to see. I think the acid's going to overpower the base here, but we're going to find out. Yeah. Yep, sure enough. Everything's going to red. All right. Let's throw some base in there. Up near the top. That's pretty. Very pretty. There it goes. A little acid at the top. Give her a spin. different acid. I have some sulfuric acid. Let's see if I can find it. Where is my sulfuric acid? Actually, I don't. It pretty much looks the same. When I add the sulfuric acid, it looks pretty much the same to me. Detonator. Do I have some fluoroantimony? I do not. I've never even seen or used the stuff myself. Never have. Be interesting though, wouldn't it, to use some of that? Here, let's add some acid up here at the top. There we go. Gotcha. It won't work, huh? I once reacted barium chloride with sodium hydroxide to get sodium chloride, and barium hydroxide and sodium chloride precipitated. Interesting. Yeah, it's tough to get sodium chloride to precipitate. You need some really high concentrations of chloride ion. Hey, great day. How are you? We're making some different colors with acids, bases, and universal indicator. Getting all the colors of the rainbow. Gotcha, Sly Fox. So you've used fluoroantimonic acid, huh? It's pretty, isn't it? Thank you, great day. It's very pretty. You can see what we're looking at here is universal indicator in water. And then as I add acid or base, that changes the color of the universal indicator depending upon the pH or how acidic or basic the mixture is. And if it's neutral, it'll look green. Then, because the reaction takes time, it's beautiful, isn't it? Because the reaction takes time, we can see some colors persist for a while. Can methane burn underwater? I don't know. I have no idea. Got it. Wow. He passed out. That sounds scary. Hey, so long, as far. Thanks for joining in. I appreciate it. Anyone know if you can burn methane underwater? My hunch is you can't. Because in my hunch, it needs oxygen to burn. Hey, everyone drop, S'more is asking, sorry if I'm pronouncing names wrong, I really apologize for that, but S'more is asking, what is your favorite inorganic element? Everyone drop that in the chat there. I'd like to know what everyone's favorite element is. Mine happens to be hydrogen. I love the element hydrogen. Anything will burn under water with enough temperature. Is that true? You get... Sulfur. We got to vote for sulfur. We got to vote for chromium. What else do we got? We got hydrogen, sulfur, and chromium. Name something that will not. Well, I'm pretty sure that no one's gotten methane to burn underwater. And by burn, I guess we should define what you mean by burn. Sodium. I'm loving some sodium. Technetium. There you go, Matt. There you go. Yeah, Rose, tell me what you mean by burn. Carbon. Nice element. Yeah, what do y'all think? That's an interesting question. Do you think anything will burn underwater as long as you get it to a high enough temperature? I think the question depends on what we mean by burn. That's an important point here. So Sly Fox says they have burned methane underwater, but they pumped in oxygen and methane. That I think could happen. That I think could happen if you got it high enough. Anything reacts with anything with enough temperature. You're 14 and he did that, huh? Interesting. A little bit of base up there at the top. But hey, y'all, there we got the rainbow at the end. I liking it. What's the use of this experiment? Well, the use of this experiment is that it's beautiful. I'm just doing this experiment for its own sake. I think it's kind of pretty. There are applications for it, but what's happening is I have added a chemical violet color develop, and that violet color tells us that we're at high pH. If I add acid, we'll go to red colors. Red colors signify that the mixture is acidic. Roy G. Biv backwards, says detonator. Yep, demonstration of pH. What's the name of the main indicator I'm using? It's a collection of indicators that we collectively called universal indicator. It's going to have 3 different compounds in it. Those would be thymol blue, phenolphthalein, and bromothymol blue, Geo. So that's we just call it a universal indicator. And you should recognize there's a bunch of different mixtures of compounds that make up different universal indicators. But generally, a universal indicator will show these colors, the colors of the rainbow, from red to violet at different pH values in the order of the rainbow. Well, hey, folks, I enjoyed the live with you today. No, pH can be negative. So pH is simply defined as, here, let me pop it in there. I wonder if I can get into the chat. Hold on, let's see if I can figure this out. I'm trying to figure out if I can actually add the chat. Hold on. Pin message. I don't think I can figure it out. Anyway, yeah, there you go. Thank you, Antonio. You are the bomb. That's what I wanted to put in the chat. Thank you, Antonio Madu. So yeah, if you look at Antonio's comment, pH is the minus log of the proton concentration. And for example, if a proton concentration would be, say, 5 molar, the negative log of 5 is a negative value. And so you can get negative pHs when you have a very high acid concentration. That's right, Rose. How do you test the pH of deep colored compounds? You know, pH sometimes does not affect the color of compounds, but sometimes it does. And when the pH affects the color of a compound, we can use it in this fashion as a pH indicator. Ooh, geez. I don't know what the pH of fluoroantimonic acid is. I think it can go down that low. You can get really low. Hey, folks, thanks for joining in the live today. Hello, Sebastian. Hey, Sebastian. What's going on, buddy? Great to see you. Sometimes I see my folks I know in the live. It's really cool. All right, hey, I'm gonna check out. Consider coming over to my TikTok this afternoon. I'll probably be doing something this afternoon live on there. Lots more people join in on TikTok, but I appreciate y'all being here today. And maybe we can get these lives going here on YouTube as well. So thanks for joining in, and I will see you all later. So long.